have been discussing with circuits with ideal op-amp and negative feedback, and you can amplify signals and do hundreds of other things. But here the emphasis is I will consider the op-amp to be ideal and how to analyze the circuit from circuit point of view. For example, you recall that in the op-amp there will be two signals you will be giving. One is inverting and another is output. Here you give VA, here you give VB, and there will be an output. But you should not forget that it is a differential amplifier, and its equivalent will be, if you look this with respect to these 3 points, it will be the voltage applied across these two terminals is VA, VB minus VA, that is what I have applied here, and this voltage will be amplified. Okay. And in general it can have an input impedance, this one, and output will be the amplified signal A times VB minus VA, and there may be output resistance also. These two are these two terminals, and what are these terminals? These two are connected to VB minus VA, not connected, sorry. So this is the thing. Now, all these potentials are with respect to ground. So, this is will be your V naught here, V naught, and VA is this one, VB is this one with respect to that common ground. How do I get this ground? From the supply to this op-amp, which is generally not shown in the circuit. There has to be DC supply given. The ground of this supply is this one. With respect to this point, VA is defined, VB is defined, and V naught is defined like that. So, but the point is the gain of this op-amp will be very large. If you sketch here VB minus VA, it will be like this. So, over a very small range of VB minus VA, the output voltage beyond this range will either become plus VTC or minus VTC, depending upon who is more, VB is more or VA is more, depending on that you will get that. So, gain is very high is one of the assumptions made. Rin is also A may be say very large, means for a good op-amp ideal sort of thing, the gain may be hundreds of thousands to 100 of into 10 to the power 6, very large gain. Similarly, input impedance could be 100K to 10 giga ohm input impedance, very high, and output impedance is very low, maybe some 10 to 100 ohms. 100 ohms is a large resistance, but compared to these values it is quite small. So, that is with respect to what we are discussing. Therefore, that is very important when you neglect some terms. For example, if somebody says that I have an op-amp which is not so ideal, but these values are given, then how to solve it? For example, this circuit we have done last time. Let us take a simple circuit like this. This is minus, this is plus. Just to tell you what is the implication of this term. This is the thing. Here you connect a suppose 2K resistance. Here you will give you input V in, which is connected to terminal A, and this one you keep grounded, and here you connect a 4K, and this is your output voltage, this is 4K. Now, if it is ideal, then what I am telling is this V naught will be this range. V naught is not negligible, it will be quite large, but to get that V naught in this linear zone, you require very little voltage across these two terminals. That is what is important. And I neglect that. If the gain is higher and higher, you will require lesser and lesser voltage existing between these 2 points, if the gain is very large. So, in case of infinitely large, to get a finite output voltage V naught, the voltage necessary will be almost 0. That was the idea. And also the input impedance is very high, therefore, no current will be drawn by the op amp. These are the external thing I have connected. Then to calculate relationship between output and input voltage, you just apply KCL here. If this is 0 volt, I will immediately say for ideal op amp, for ideal, I will say this is 0 volt. So, this is also 0 volt, nothing doing, almost 0 volt, and ideal op amp 0 volt. So, what will be this current? Current is just one line calculation, V in, voltage across the resistance will be then V in, with respect to ground all potentials are calculated, minus 0 potential of this point with respect to ground. I have indicated arrow this way. So, this divided by 2K. If V is in volts and resistances are kilo ohm, the currents will be in milliampere. Okay. Then what will be the current this way? This current will be potential of this, which is 0 volt with respect to ground, potential of output. In any case, I have defined it to be V naught with respect to this ground. Therefore, voltage will be this current then will be equal to 0 minus V naught by 4K. And for you can easily see V naught will be equal to minus 2 V in. So, it will amplify the input signal. If it is sinusoidal with 1 volt peak value, it will become also sinusoidal, peak value will be 2 volt, but it is reversed in sign. There will be 180 degree phase difference, that is okay there, but it will nonetheless amplify the signals. Now, suppose let us say that this op amp, the same circuit, I will give you some numbers. Say let the op amp is not ideal and it has got this thing. Suppose this R in of the op amp is say 1000 K or 100 K, let us assume. Okay. And gain is suppose 10,000. Quite large gain. And let us assume R naught I can assume, but let us assume the output resistance, this is 0. I do not want to make it more complicated. Complicated means nothing like what you have to do now. In that case, if it is these two informations are there with R naught equal to 0, then I cannot claim that the current drawn by the op amp through this path is 0. So, what will be KCL at this point? So, it is now like this. This point need to be emphasized. This is grounded, I have grounded plus, and here there is a 2K resistance, and here I am giving you V in, that is there. But between these 2 points, there is now a resistance, I am telling, input resistance, and between these 2 points, of course, 4K is connected. It is like this. Now, while writing down KCL at this point, KCL at A, my goal is to find out V naught, what it will be. I will say this voltage, I cannot say it is 0 volt now. Let us say that voltage is VA. So, I will say V in minus VA divided by 2K, current this way, it comes here, then current goes this way plus V in VA minus V naught divided by 4K, this is the current going this way, this I have calculated, plus this current also, that is plus VA by R naught, and R naught value is 100K, suppose I have assumed like that. So, that is what, and this is equal to 0, got the point. So, V in VA, this will be the thing. Okay, I want to find out V naught. What are the things known here? V in is known, VA and V naught are the unknown things. Now, the question is, what is VA? If you see, this VA is this current drawn into R naught. Therefore, so I have to generate another equation to solve for another equation I have to find out. What will be that equation? That equation will be is that this things is correct. So, what will be the second equation? Second equation will be A factor will come, because this is the equation. I have to now go through this. So, this voltage V naught here is A times VB minus VA. So, the second equation will be what is the thing to be done? V output is equal to A times VA minus 0. So, VA minus 0. This is the other relationship. Now, what is these things? V naught is equal to A, I have been told that A is 10,000, then 1, 2, 3 into VA. This is what has been given to me. Therefore, if you want to calculate VA, V naught, so convert this to, so you can do that, or VA is equal to V naught by 10,000. So, I will put that in. So, let me just write down it will become slightly more involved in calculations, nothing else. So, V in by 2, and for V A I will substitute V A I will remove. So, V naught by 1000, V naught by 1000 here, plus V naught by 1000 here, 10,000, I have assumed the gain to be like that, minus V naught by 4 second term, plus once again V A. So, V naught divided by, why this 1000 where from I got? R. So, V A, V naught divided by 1, 2, 3 was already there, then 10, 1, 2, 3. This will be equal to 0. Now, V naught can be solved. I am not going to solve, but I can easily solve V naught. It is a single equation with single variable. What I am telling, V naught will be very close to your 2 times V in. Assume V in to be 1 volt, it may be 1.9999 volts. Which KCL? This equation V in minus is V in minus A by 2 coming in. Oh, so this will be equal to this, is not V A by 0. So be careful about this current coming in, this is how I have written. So, these things will be then here it will be 0. Please tell me right at that point. So, this is the thing. So, I can solve for V naught, and V naught will be close to 2 V n. Therefore, even if the input impedance value or gain is known, but if it is really large, we do not care. So, we will be henceforth assuming the op amp to be ideal. Okay. Let us take few more examples. One example is this one. Suppose you have got a circuit like this. Solve more problems. So, here it is inverting, here it is non-inverting, and the values of the resistances are, suppose this is R 1, this is R 1, and here is a point R 2, and this is grounded, okay. And here is a negative feedback. Negative feedback is necessary through a passive element, either R, L or C. There should not be any source here. Okay. So, this is output voltage V naught, ideal op amp. Ideal op amp, and this resistance is also suppose R 2, and here I will connect a signal V A and another input signal V B. So, 2 inputs to be connected, it is connected like this is R 1. Now, how to analyze this circuit, and very quickly we have to do it. First thing, this is an ideal op amp. So, its input impedance is very large. Therefore, there will be no current, practically no current drawn by the op amp. There will be no current here in this branch or in this branch. That is what I will assume. And also, if no current flows, therefore, the potential between this point and this point, that is the thing which gets amplified, this potential of this and this points has to be same, is not? But note that this point is not now grounded. So, I cannot say this is at 0 volt, this is at 0 volt. So, what I have to do? Let me put it so that in the context let this signal be V1, this signal be V2, and these are the input signal to the op amp VA and VB. That is what we are doing. Now, since no current is drawn, therefore, what will be VB? I will calculate first VB, because I am sure VB will be equal to VA. VA and VB has to be same. There will be no drop taking place here practically, because to get a finite output voltage, the difference of this voltage VA minus VB, this difference will be very small. Ideal op amp, it is 0. Therefore, potential of this point has to be equal to potential of point A, another input point. Now, what is VB? VB is, you see, if some current flows here, this current comes here, this current cannot be entered into the op amp, will not draw any current, no current can exist. Therefore, the same current has to flow like this. So, what will be VB then? VB will be this current which is independent of these things, nothing is connected, because no current is drawn here. So, V2 divided by R1 plus R2, this will be this thing, into R2. The potential drop between these 2 points is your VB with respect to this point. If this is VB, I will say this is also equal to VA, and you are done. Therefore, the moment I know this potential, then I will write KCL here, KCL at this point. What is KCL? This current is V1 minus VA divided by R1, and what is this current? This current will be VA minus V0 divided by R2. Look at these arrows I have given. So, VA minus V0 I have to do before dividing R2 to get this left to right current. Similarly, left to right current V1 minus VA, all potentials are with respect to this common ground point. So, this will be the thing. What is our goal? Our goal is to obtain V0. Therefore, let us calculate that. So, V2 VB is this one, which is equal to this. So, here you get V1 by R1, let us separate, minus VA by R1 is equal to VA by R2 minus V0 by R2, if any mistake point out, or I will say VA into 1 over R1 plus 1 over R2, that is these two terms, this I have taken to this side, will be equal to V1, and I will keep V0 on one side, okay. And so, I have taken this term to this side, then say minus V1 by R1, and this will be equal to V0 by R2. I can do that, and then this is the thing. So, but VA is equal to this, or because input signals are V1, V2. So, V1 is there, I am happy, here VA is there, that should be expressed in terms of input voltages, and this I have already found out. This is the thing, VA is equal to, from this to this, if you do, VA is R2 by R1 plus R2. For VA I am writing into V2, and this is 1 over R1 plus 1 over R2 is already there, into this, correctly written, into V2, and this one is minus V1 by R1 is equal to V0 by R2. This will be the thing. See, this the important point is potential of this point and this point are same. If it has got a negative feedback and op amp is ideal, V0 will that is the op amp is in the saturation non-saturated zone, linear zone it is operating. Therefore, there will be practically no voltage difference between these 2 points. It will be like this. So, this one if you calculate, this will be R2, this R1 plus R2 will cancel out, divided by R1 R2 into V2 minus V1 by R1 into V0 by R2. I want to calculate this difference in voltage. So, this R2 cancels. So, you will have V2 minus V1 divided by R1 is equal to V0 by R2, or I will say that V0 is equal to R2 by R1 into V2 minus V1. That means, this network is what it is going to do. It is taking the difference of 2 input signals and amplifying it. If R2 equal to R1, it will simply be a subtractor circuit. 2 signals, in signal processing you often require to add signals, subtract signals, things like that. So, here is a circuit which subtracts input signals. Very interesting circuit. So, what is the step involved? First check whether there is a negative signal, then it is in amplifier mode, and then you this voltage and this voltage, these two should be equal for a finite output voltage, and you write KCL at this point, you write down KCL, and that will be one equation, and then what is VB? The current here, this current has to be 0. If that is to be 0, then in this circuit I can calculate VB in terms of input signal. So, VA and VB should be expressed in terms of V1 and V2, that is all. That is what we have done. Okay. So, express this input voltages in terms of these are the input signals, not VABV, input signals. I think you have understood this. Clear? Acha. So, this is called a subtracting circuit, subtracting 2 signals. Similarly, you can easily see you can add these 2 signals. For example, if you have 2 resistances and if you have, the calculations are very simple. One, this idea is there. Suppose you have this 2 and this is grounded and this is your output pin where you give a negative feedback with a resistance say R0, R2 say, and let us say this is R1 and this is R2, and here I will connect a signal V1, here I will give a signal V2 all with respect to this ground, and that is it, V0 R1 R2, and this potential, and suppose the op amp is ideal and it is operating in linear zone, then I will say potential of this is A, this is B, this is the clue, V A must be equal to V B, but this time V B is equal to 0, that is all, grounded. Then you write KCL at this point, KCL at this point, KCL at the red terminal. KCL is very simple because this is 0 volt, you write down. So, this current is V1 minus 0 by R1 straight, this current plus V2, this is also say, let us say R1, correct it. Suppose these two resistances are equal. So, V2 by R1, V2 minus 0 by R1, this current. What will be the current in this branch? 0, because it is an ideal op amp. If it is not drawing any current, the sum of the current must draw through this point. So, this plus this must be equal to 0, and this potential is V0 with respect to this. So, 0 minus V0 by R2 it will become, is not, or I will say V0 is equal to minus of, if you bring all this thing this side, R2 by R1 into V1 plus R2 by R1 into V2, this will be the thing, bring R2 this side appropriately. So, this is equal to minus R2 by R1 into V1 plus V2. So, this signal, this circuit adds two signals provided here. You could have more signal V3, that will also get added up. If R1 equal to R2, it will be simply adding the signals, otherwise the signals will be added and will be amplified by this factor, and do not forget about the negative sign, it will reverse the that 180-degree phase shift. Okay. So, it will add two signals, multiply it with the amplification factor and then reverse its sign. Anyway, thank you, we will continue with this.